So this is the Physical Science Section 6.3 lesson video, and as always, if you like my videos all in one spot, then just subscribe to my channel and you'll have them for the whole year. So today we're going to talk about naming compounds and writing formulas. So we've talked about ionic bonding and covalent bonding, but how do we know what those formulas are going to look like? How do we know what we name them? So when the name of an ionic compound must distinguish the compound from other ionic compounds containing the same elements. The formula of an ionic compound describes the ratio of the ions in that compound. So a compound made from only two elements is called a binary compound. Di and bi are both prefixes that mean two. When naming an ionic compound, the name of the metal or the cation does not change, and the name of the nonmetal or the anion has the suffix "-ide". So we talked about sodium chloride. So like for example, right here we have MgBr2. So Mg is positive 2, it's magnesium, so we call it magnesium. Br is bromine, so we call it bromide. Now notice in the name, there is nothing that indicates that there is a 2 at the bromine. Okay, so the name is not going to tell you that. So here's some other examples. NaCl, sodium chloride. NaF, sodium fluoride. CaO, calcium oxide. And again, we have a 2 here, but the name does not indicate that at all. K2O is potassium oxide. MgCl2, magnesium chloride, so forth and so on. So the subscripts do not change the name of an ionic compound. Many transition metals form more than one type of ion. That's why we don't label the charges on the transition metal section. So when a metal forms more than one ion, the name of the ion contains a Roman numeral to indicate the charge. So for example, iron could be positive 2 or positive 3. If it's positive 2, it's called iron Roman numeral 2. If it's positive 3, it's called iron Roman numeral 3. So the Roman numeral just indicates the charge on the metal, because transition metals can have more than one charge. A covalently bonded group of atoms that has a positive or negative charge and acts as a unit is called a polyatomic ion. So polyatomic ions, you don't need to memorize them. They're just a group of atoms with a charge. So for example, Cl has a negative charge. Cl is just one atom. But OH, when they bond together, they can have a negative charge. Or ClO4, so Cl and 4 oxygens can have a negative charge. And so they act as one group, and all the polyatomic ions have their own name. And so you would be provided with a list of these if you needed to name those. So, writing a formula. Place the symbol of the cation first. So the cation is always listed first. Remember, cation is the positive one. Followed by the symbol for the anion, which would be your negative ion. Use subscripts to show the ratio of the ions in the compound. Because all compounds are neutral, the total charges of the cations and anions must add up to be 0. So for example, Ca has a positive 2 charge. F has a negative 1 charge. So we need 2 Fs, so that then we'll have a positive 2 and a negative 2 charge and make it neutral. So it becomes CaF2. On the other hand, Al is positive 3. O is negative 2. So the only way to get those to cancel out is to make them positive 6 and negative 6. So I would need 2 Als, that's positive 6, and 3 Os, that's negative 6. So it becomes Al2O3. Now some of these, they get kind of complicated, so I'm going to show you an easy way to do this. And that is called crossing charges. So to balance the charges in an ionic compound, you can cross the charges if they are not the same. And if they are the same, you don't need to do anything. So for example, I have Ca positive 2 and Cl negative 1. I can take the 2 only, not the charge, just the number, and cross it down. And so I get CaCl2. Now here we have Ba plus 2, O minus 2. These already cancel, so I don't want to cross anything. So it's BaO. Here we have K plus 1 and S minus 2. So I take the 2 only, not the negative, and cross it down to the K. So it becomes K2S. Here I have Fe positive 3, Br minus 1. So I take my 3 only and cross it down to get FeBr3. What the crossing of the charges does is it allows the charges to cancel. Okay, so see here I have a Cr positive 3 and an O minus 2. So I cross the 2 down to Cr and the 3 down to O, and so it becomes Cr2O3. Okay, so all you do is take the numbers only and cross them down. But notice we don't need to cross down a 1. It's already understood that we have 1 Mg. We don't need to put a 1 down there. And so crossing charges just allows you to balance those charges and make them cancel out. So the Neyman formula of a molecular compound has to describe the type and number of atoms in a molecule of that compound. Molecular compounds only contain nonmetals, so we won't be using any metals because remember there's no charges involved in these. The name of the first element is the same. The name of the second element ends with the suffix "-ide" again. Prefixes tell us the number of atoms of each element. A prefix is not used when the first element has one atom. So CO2, C is carbon, O we're going to call oxide, and because there's two O's, we're going to use the prefix di for 2. So let's look at what those prefixes are. So here are your prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So those tell us the prefixes for that amount of atoms. So when we're writing molecular formulas, well, you write the symbol for the elements in order, the order the elements appear in the name, and the prefixes indicate the number of atoms of each element in this molecule. So we have diphosphorus pentoxide. So phosphorus is P, oxide is O, di means 2 phosphorus, and penta means 5 oxygen. So we get P2O5. And notice we don't use prefixes in ionic bonds with the metal and the nonmetal. So, section assessment. What does the formula of an ionic compound describe? It tells us what types of elements and the ratios the ions bond in. Okay, it tells us the types of elements and the ratio that the ions bond. Number 2, what do the name and formula of a molecular compound describe? Well, they tell us the number and types of atoms. The number and types of atoms in that molecule. So number 3, what suffix is used to indicate an anion? Remember, cation, the name does not change. An anion, we add "-ide" to the end. So the suffix is IDE, "-ide." Number 4, why are Roman numerals used in the names of compounds that contain transition metals? Well, transition metals can have more than one charge. So the Roman numeral tells us what charge that ion has. Okay, so Roman numerals are there to tell us the charge of the ion because transition metals can have more than one charge. And then number 5, what is a polyatomic ion? Well, the name gives it away. Poly means many, atomic means atom, ion means it has a charge. So it's many atoms bonded with an overall charge. Many atoms bonded with an overall charge. Number 6, how is it possible for 2 different ionic compounds to contain the same elements? Well, for example, the transition metals, they can have more than one charge. So I could have iron with a +2 and iron with a +3, and they could both bond with Cl, and so then when I cross that charge down, they both contain Fe, or iron, and chlorine, but they have different charges because, they have different numbers of chlorines because they have different charges. So how is it possible for 2 ionic compounds to contain the same elements? The charges are different. The charges are different. So number 7, how many potassium ions are needed to bond with a phosphate ion? Well, potassium is K, and because it's in group 1, it has a +1 charge. And then phosphate is one of the polyatomic ions. So if you look at that one, it's PO4 -3. So I would need to cross my 3 down. So how many potassium ions are needed? It would be 3. 3. Number 8, what are the names of these ionic compounds? Well, remember, we keep the first element the same, we change the second element to "-ide." So this would be lithium chloride, barium oxide, and sodium, what is nitrogen when you add "-ide"? Nitride. Okay, sodium nitride. So when you're naming your ionic compounds, just name the first element and add "-ide" to the second element. So number 9, name the molecular compounds with these formulas. So we have N2O7. So I would call this dinitrogen because there's 2 of them. And then our prefix for 7 is hepta. And then oxygen becomes oxide. So it would be dinitrogen hept oxide. Dinitrogen hept oxide. Alright, and then we have CO. Now we don't ever use mono for the first element. So I'm just going to call C carbon, but we do use mono if the second element only has 1. The only time you don't use a prefix is when the first element just has 1. So we say carbon monoxide because oxygen becomes oxide. Don't forget to change the ending of that second element. So carbon monoxide. And then number 10, what is the formula for the ionic compound formed from potassium and sulfur? Alright, so it's getting kind of low, so I'm going to do it right here. So potassium is K, and it has a +1 charge. Sulfur is S, and it has a -2 charge. So we have to take our 2 and cross it down. So our formula would be K2S. K2S. Alright, so hopefully now you know a little bit more about naming and crossing charges to write formulas. I will go ahead and tell you this is something a lot of my chemistry students struggle with, and this is spread over 3 chapters in chemistry, and we're cramming it into 1 in physical science. So just get prepared to be doing a lot of practice in class.